We go next to chapter 9, a short chapter. We just cover a few sections. Chapter 9 is differential equations. And you see in 9.1, it's an introduction. So we're going to learn what these are, and that's going to set us up for the remaining sections where we explore and we start looking for solutions, trying to solve the differential equations, that sort of thing. But that won't be the case in the intro. We're just going to learn some terminology, starting with just what a differential equation even is, and we're just going to see what these things are all about. On that note, there is an entire course known as differential equations. And so what we see in this course, we really just get a flavor for it. We don't explore near the depths that are differential equations, and there's even more courses devoted to differential equations at the university level, even beyond what we would offer. Okay, so let's get started. 9.1, the introduction. Let's start off. Probably a good place is just to define a differential equation. Okay, so you see in the name kind of gives part of it away. So it is an equation, and the goal will be to solve the equation. Differential tells you that somehow derivatives are involved in this. So it's an equation containing an unknown function and its derivatives. Let me give you an example because these feel very strange at first, and a lot of students, it takes a little bit of time just to wrap your head around what a differential equation even is and how to work with them. So quick example here, this equation contains an unknown function. When you're looking at that, the unknown function is y, and it contains the derivatives of y. So let me read it. X squared y double prime, let's make that a little bit clearer. X squared y double prime plus xy prime minus y equals 0. So we have an unknown function y, and we have y prime and y double prime. We also have x and x squared, and you could involve constants, right? And in this case, it happens to be equal to 0. That's not always the case. But I think this is a great one to just show us the idea. So what would we want to do? Like, what would a solution be? Okay, that's coming pretty soon, what a solution actually is. But for now, let's just, okay, it involves a function y and some derivatives of y, and x gets thrown in there as well. Okay, here's another one. This one involves t as the independent variable. So we've got dy over dt equals 6t times y. So it's not uncommon to see your independent variable being t, although usually it's x. And in this case, the derivative of y is represented not with a y prime, but with a dy over dt. Well, okay, no big deal, right? Now notice this one, it only has the first derivative of y, where a moment ago we had y prime and y double prime. And one thing to point out is the higher the derivative, whatever is your highest derivative, the more difficult it usually is to solve. Where this one just has the first derivative. Okay. And notice even here the first derivative has been isolated. So a lot of times we like that when that first derivative has been isolated, which isn't the case here. Okay, just some things to point out. Don't take anything I'm saying as, like it has to be isolated. That's definitely not the case, but it's just kind of, we notice this stuff. Okay. Let's define what a solution to a differential equation is. That's a good idea. We're trying to find that unknown function, a function y which makes the differential equation true. What is that unknown function? So that if we knew what the function was, we could plug it in, and we could plug in its first derivative, and we could plug in its second derivative, and that would make the whole thing come out to be 0 up in this case. Or in the second one, what is that function y? So if I was to put the function y here, and if I was to take dy over dt and put that here, then we would get the same thing. We'd get a true statement. Same thing on both sides. That's what differential equations are all about. Can we find that function? Obviously, there is more to it. We can go deeper, but that's the big scheme of what these are all about. Okay, so we're going to get to some examples here. Now, here's where a lot of times students get thrown off. Here in 9.1 in the intro, we're not going to be learning any solution techniques. We're not going to be solving the differential equations yet. We're just being introduced to what they are. And that throws a lot of students off because they're thinking like, what, like, they're just getting confused about what we're even doing. Why aren't we solving these? And, they're just kind of struggling with, wait, aren't we, it's almost like it's so simple, it's confusing what we're even trying to accomplish. Okay, so here's what I'd like you to do. Go back, think back to your very first day of algebra. Okay, this way, way back. Okay, so you just learned about variables, like the variable x. And you're eventually going to learn how to solve equations that have x in them to solve for x, but you're not there yet. It's the first day. What did they do? So on the first day of algebra, or early on, before you learned how to solve equations, what happened was they gave you an equation and then they told you what the x value was, and you were asked to verify it. Okay, so that's what we're about to do. Let me go back before we get to this next example. So let me give you an example of what I'm talking about. So let's say, what if we had, I'll try and make up something with some good numbers. So let's say, let's go with like 3x plus, I don't know what I'm doing here, plus 2 equals 17. Okay. So you'll see this equation, 3x plus 2 equals 17. And you haven't learned how to solve these yet. So they're going to say, verify x equals 5 is a solution. Okay, they're going to tell you what it is, but it's your job to verify it or confirm it. So you would say, okay, x equals 5. So I'll put that in here. I'll plug it in. And I don't know, is that really the case? Okay, so, you're just learning this. So 15 plus 2, 17. Yes, 17 equals 17, right? So they told you the answer. And it's just a matter of plugging it in and confirming. That's what we're doing in this section, okay? We're not finding these solutions ourselves. That will come in the next section. We're just confirming these. Okay, verify the solution. So part A, we're given the differential equation. That's the same one we just saw. X squared y double prime plus xy prime minus y equals 0. And here's the solution. They're just telling us this. The solution is y equals 1 over x. Okay. So let's verify that that really is the solution to that differential equation. How are we going to verify y equals 1 over x really solves this? Okay, well, we know what y is, so eventually we'll plug 1 over x in right here, but we also need its derivatives. So we need to find y prime and y double prime. Then we'll plug in y prime, and y double prime, and we'll confirm that that really is a true statement. Well, that's not too bad, right? If y equals 1 over x, then y prime equals negative 1 over x squared. And y double prime, taking another derivative, is positive 2 over x to the third. You might take, a step in between to find these derivatives. That's okay. But I'm going to be confident that you guys can follow what I'm doing here. Okay, so we know y, and we used y to find y prime and y double prime. And now we're going to plug all these three in, and we're going to confirm that we get a true statement. So I'm going to say, all right, x squared times y double prime. Well, y double prime is 2 over x to the third. Plus x times y prime. Well, y prime was negative 1 over x squared. Minus y. Well, y was 1 over x. So now you notice everything is x's. And we know this thing equals 0. Okay, so the point is now, does this really equal 0? You know, when I plug in the 5, do I really get 17? And we gotta show all the steps. We can't just say yep and move on. We gotta break it down. Okay, so we're gonna simplify. So we're gonna cancel out some x's, and we get to this. 2 over x minus 1 over x minus 1 over x equals 0. Is that really true? Okay, yeah, I think we can say, yep, 2 over x minus 1 over x minus another 1 over x. That left side is 0 and that right side is 0. It's been verified. We just need to put maybe a check mark or something next to it. It has been shown. And of course that causes you to think, how did they know the solution was 1 over x in the first place? Okay, that's beyond our scope right now. Like back in algebra, how did you know it was 5? Well, okay, subtract 2, divide by 3. Okay, but we don't know that yet, so we're just going to plug that in. All right. Trying to really, it's hard to kind of break, go back that and be that simple because we're used to doing things much more difficult. We will soon enough. Let's do another one of these. Part B. Let's try that dy over dt equals 6ty. That's our differential equation. And we're just going to tell you the solution. The solution here is y equals e raised to the 3t squared. All right. Y equals e raised to the 3t squared. So let's verify that that is the solution. So what we're going to do, we're going to say, okay, in a moment, I'm going to plug this in right here for the y. But first, I'm going to use y equals e to the 3t squared to figure out dy over dt because I need to plug that in on the left side here. So let's get it from y equals e to the 3t squared. Dy over dt equals e to the 3t squared times 6t. So that's dy over dt equals 6t e to the 3t squared, right? So I'm just rewriting that. I used y to figure out dy over dt. Okay, now I'm going to take this and I'm going to plug it into the left side. And I'm going to say that equals 6t, and I'm going to take this and I'm going to plug it into the y. Now, in this case, there's not going to be any other manipulations that we need. We're going to get it. Okay, I don't know what I was thinking right here. So we're going to take this right here and we're going to plug it in right there. 6t e to the 3t squared. And then we got 6t. And we're going to take this and put it in for the y, e to the 3t squared. Hey, are those equal? Are those really equal? Okay, of course. Yeah, duh. All right, there's nothing else to do. Yeah, the left equals the right. It's confirmed. It's confirmed. We did it. Okay. Let's stop this video here. I think this is a great start.